In this video, the resistivities of two different wires will be calculated by plotting VI graph of the Ohm's law. This is a setup where battery eliminator is connected to the ammeter. The red terminal of the ammeter is connected with the red terminal of the battery, and black terminal is connected with the red terminal of the voltmeter. Like red is positive is connected with negative of the ammeter. This is a series combination. An unknown wire, which is 100 centimeter constant wire, is connected in parallel, and this is connected to the one of the lower terminal of the rheostat, and the upper terminal of the rheostat is connected to the black terminal of the battery, which is connected to the black of the voltmeter, and red of the ammeter connected with the red of the battery eliminator. Now, in order to take readings, resistance of the circuit will be changed by using variable resistor called rheostat, and it is found at 100 milliampere. The voltmeter reading is of 12 lines. Then again, by changing the resistance of the circuit, the current of the circuit will be changed, which is coming at 120, that is 12 line current, 120 milliampere, and the voltmeter is showing 16 lines reading. Again, for the next reading, the resistance of the whole circuit is changed by varying the pointer on the rheostat, and the current is 160 milliampere, and voltmeter showing 21 lines reading. For the next reading, again resistance of the circuit is changing, and current is coming out 200 milliampere, and voltmeter showing a reading of 28 lines. For the last reading, rheostat is changed its value, and the reading is 240 milliampere, and voltmeter showing 35 lines reading. Now for the another wire, the same circuit has been set up, but now the wire is manganin and 150 centimeter long. For the first reading, rheostat is been changed its position, and voltmeter showing one line deflection at the current of 130 milliampere. For the second reading, voltmeter is showing the two lines deflection at the current 200 milliampere, and in the next reading, voltmeter is showing three lines deflection for the current of 3 250 milliampere. Again, the rheostat is changing its value, and the voltmeter is showing 3.5 lines deflection at 300 milliampere. Again, by changing the position of jockey on the rheostat, the voltmeter is showing 4 lines deflection for the current of 380 milliampere. This is the current of 38 lines, and the last reading, voltmeter is showing 5 lines deflection at 450 milliampere of current. Now the time to find the diameter of both the wires, where a screw gauge would be taken, and first of all its zero error will be calculated. Here, zero on the circular scale is around 7 lines below the reference line, so there is a zero error of minus 0.07 millimeter, which will be added in the final reading. Now, first constantan wire is being introduced between the jaws of the screw gauge, and it is noticed that the linear scale reading is 0, and the circular scale reading is 45, that is 0.45 millimeter. Now for the manganin wire, linear scale reading is 0 and the circular scale reading is 56. Now all the readings of the Ohm's law circuit for the two different wires are tabulated in the observation table. In this table, all the lines are multiplied by the least count for the both voltmeter ammeter reading, and graphs are being plotted by using these readings from where we can calculate slopes, and the slope of vi graph will give us resistance of two different wires. For manganese wire it is 1 ohm and for constantan wire it is 7.5 ohm. Then the readings taken from the screw gauge will be used to calculate the diameter of two wires. For manganese wire it's 0.49 millimeter, for constantan wire it is 0.38 millimeter. Now all the values will be substituted in the formula of resistivity, and the resistivity of constant wire and the manganese wire can be calculated theoretically as shown in the result. Thank you.